In this problem, we have a binomial times a binomial. We have two terms times two terms. So what do? We FOIL. The first times the first is x squared. The outer times the outer is minus 3x. The inner times the inner is plus 2x. And the last times the last is negative 6. Once we have FOILed, we combine our like terms. And generally, that's the two middle terms. So negative 3x plus 2x is negative 1x minus 6. This problem is very similar. We have a binomial times a binomial. So we're going to multiply the first times the first. Well, they're both square roots, so we can push them together under one square root. 3 times 2 is 6. Outer times outer, well, it's going to be positive. Square root of 3 times square root of 3 is 3. Now we'll multiply our inners. Well, a positive times a negative is negative. They're both square roots, so we can push them together as the square root of 5 times 2, which is 10. And now the last times the last, positive times a negative is negative. They're both square roots, so we can push them together under one square root. Don't forget that you're multiplying. 5 times 3 is 15. Now we look to see, can we simplify any of these radicals? Well, there's no perfect square factors here, no perfect square factors here, and no perfect square factors here. We cannot simplify any of our radicals. Do we have any like terms? Well, none of these radicals have the same radicand, and of course this is the only constant. This is our final answer. Let's work through these examples now. Again, a binomial times a binomial. The first times the first, well, 2 times 7 is 14. The outer times the outer, well, the result is positive. Now, 2 is not under a radical, and 10 is under the radical. We can't push those together. We can just say it's 2 times the square root of 10. Inner times inner, positive times negative. And of course, 5 is under the radical, 7 is not. They have to stay that way. So all we could say we have is 7 times the square root of 5. And now the last times the last, we have a positive times a negative. They're both under radicals, so we can push them together and say it's the square root of 50. Our next step is to see if we can simplify any of the radicals before we try to add. Well, the square root of 10 has no perfect square factors, so we can't simplify that. The square root of 5, well, 5 has no perfect square factors. When I say we can't simplify it, it's in simplified form. However, the square root of 50 does contain a perfect square factor. 25 is a perfect square, and it goes into 50 twice. So we have 14 plus 2 square root of 10 minus 7 square root of 5 minus 5 square root of 2. Now we look to see if we can add or subtract. In other words, can we combine like terms? Well, we don't have any like terms. The radicands are all different, so we can't combine any of these. This is our final answer. Again, we have a binomial times a binomial. So the first times the first, well, they're both under radicals, so we can push them together, and we get the square root of 2 times 6, which is the square root of 12. Outer times outer, positive times negative. And square root of 2 times the square root of 2 is 2. Inner times inner, positive times negative. They're both under radicals, so we can push them together and we get the square root of 6 times 3, which is the square root of 18. And now the last times the last. Well, a negative times a negative is a positive. They're both under radicals, so we can push them together and say it's the square root of 3 times 2, which is 6. Next step. Can we simplify any of these radicals? Do any of them contain perfect square factors? Well, 12 does. 4 is a perfect square, and it goes into 12 3 times. And that's 2 square root of 3. Minus 2. What about 18? Well, that has a perfect square factor. That has 9. So we can pull it apart. Perfect squares, whatever's left. So it's minus 3 square root of 2. Plus, and 6 has no perfect square factors. So we just put the square root of 6. Now that all our radicals have been simplified, do we have any like terms? No, we don't. They all have different radicands, and this one has no radical at all. Be very careful on this last problem. You cannot distribute an exponent over addition or subtraction. You need to write these out. 5 minus the square root of 3 times 5 minus the square root of 3. Okay, so now we're multiplying two binomials. The first times the first, 5 times 5 is just 25. Outer times outer, positive times negative, and we have 5 times the square root of 3. Inner times inner, negative times a positive, and we have 5 times the square root of 3. The last times the last. Well, the square root of 3 times the square root of 3 is 3. And a negative times a negative is a positive. Do we have any radicals that we can simplify? Well, there are no perfect square factors here or here. So we're ready to combine like terms. 25 plus 3 is 28. Negative 5 square root of 3 and negative 5 square root of 3. It's like if we had negative 5x and negative 5x, we'd have negative 10x. We get negative 10 square root of 3. Here we have two binomials being multiplied. Notice we have the same two terms, but opposite signs in the middle. And what happens? The first times the first, x times x, gives us x squared. The outer times the outer, well, positive times a negative is negative, and 2 times x is 2x. And the inner times the inner, well, a positive 2x. And then the last times the last, a positive times a negative is a negative, and 2 times 2 is 4. What happens here when we have the same two terms but opposite signs? Well, the inners and outers are the same, but they have opposite signs, and they add up to 0. And we wind up with the first times the first minus the last times the last. We have a similar situation here. We have a binomial times a binomial, but more than that, we have the same two terms, but opposite signs in the middle. Let's see what happens. The first times the first, 3 times 3 is 9. The outer times outer, well, positive. And then 3 times the square root of 7. Inner times inner, well, we get a negative. And we get 3 times the square root of 7. Last times the last, positive times a negative is negative. And the square root of 7 times the square root of 7 is 7. Combining like terms, well, 9 minus 7 is 2. And 3 square root of 7 minus 3 square root of 7 is 0. Interesting, we have no radicals. Let's see what happens on this one. Well, the first times the first, the square root of 2 times the square root of 2 is 2. Outer times outer, positive, and they're both under radicals, so we could push them together and say it's the square root of 10. Inner times inner, well, it's negative. And again, both under radicals, we could push them together and say it's the square root of 10. And last times the last, the square root of 5 times the square root of 5 is 5. Of course, it's negative. Well, look here. The inners and outers add up to 0. And we wind up with 2 minus 5, which is negative 3. In fact, these are called, let's go down here, conjugates. They have the same two terms with opposite signs between them. They are going to be very important when we get to the next section on dividing radicals.